afternoon. For today's topic, we'll be talking about spread of disease model. So, a contagious disease, for example, a flu virus is spread throughout a community by people coming into contact with other people. So, let n be the total population. Let x of t denote the number of people who have contracted the disease, and let y of t denote the number of people who have not yet been exposed. So, the rate dx over dt at which the disease spreads is proportional to the number of encounters or interactions between these two groups of people. If we assume that the number of interactions is jointly proportional to x of t and y of t, that is proportional to the product x, y, then dx over dt equals kxy, where k is the usual constant of proportionality. Suppose a small community has a fixed population of n people. If one infected person is introduced into this community, then it could be argued that x of t and y of t are related by x plus y equals n plus 1. Using this last equation to eliminate y in 4 gives us the model dx over dt equals kn n plus 1 minus x. An obvious initial condition accompanying equation 5 is x of 0 equals 1. So for the next part, Adrian is here to explain the next part. So in to solve this expression dx over dt equals kx n minus x, supposedly x0 is equal to 1, we can use the separation of variables, integrating and simplifying. So in this case, dx over x n minus x is equal to k dt. So by dividing x n minus x, we can get dx over x n minus x, and with multiplying dt, we could get k dt. So integrating the 1 over x n minus x dx and the integration of k dt, we can use the partial fraction for x for integration. So we can write this expression into 1 over x n minus x equals to a over x plus b over n minus x. So we can use cover-up method to find a. Simply, we cover this x and put x is equal to 0. So which means a is equals to n minus 0. Then simply a is equal to 1 over n. So in this part, b over n minus x, we can cover this n minus x. So the remaining part is b over x. And to find b, put n is equal to x. So we'll replace n with x. So b is equal to n, and simply b is equal to 1, and so same as finding a. So we can continue for the integration, and we all know that the integration of 1 over x is equal to natural log of x and negative 1 over n minus x. The integration of this is natural log of n minus x equals to kt plus c. So by simplifying, natural logarithmic of x over n minus x is equal to nkt plus nc. So we simply simplify this term into x is equal to n minus x is equal to e raised to nkt plus nc. So we simply put x over n minus x equal to e raised to nkt, and this term we can replace it, c1 is equal to e raised to nc. So it turns to x equal to c sub 1 e raised to nkt times n minus x. So we can now obtain this expression x equal to n c sub 1 e raised to nkt over 1 plus c sub 1 e raised to nkt. So we can simply divide this e raised to nkt so that the remaining numerator will be n c sub 1, and then this e nkt will now become c sub 1 plus e raised to negative nkt. So we now obtain this general solution for the IVP, and the initial condition supposedly that a person carrying a virus, so t is equal to 0 and then x is equal to 1. So now t1 is equal to 1 over n minus 1. We can use this expression to apply it to the general solution. This general solution, and now we get and simplify it, and now we get x of t is equal to n over 1 plus n minus 1 times the e raised to negative nkt. So now this becomes the solution for the initial value problem. So the example will be discussed by Aldrin Baal. So for the example, suppose a student carrying a flu virus returns to an isolated college campus of 1,500 students. So it is assumed that the rate at which the virus spread is proportional not only the number of infected students, but also the number of students not infected. Determine the number of infected students after 6 days, given that the number of infected students after 4 days is 60. So for the solution, this is the equation we will be using. X of t equals n, this is the population, over 1 plus the quantity of n minus 1 e raised to negative k t. So x of t is the infected students, equals 1,500 is the total population of college students, and 1 plus 1,499 e negative k and 4. 4 is the days. So 1 plus 1,499 e raised to 4k equals 1,500 over 60. So we just divide 1,500 by 60, so we came up with 25. So 1 plus 1,499 equal 1,499 e raised to negative 4k equals 25. So we just transpose the 1, so it became 24 over 1,499. E raised to negative 4k equals 24 over 1,499. So after that, it will become negative 4k and natural logarithm of 24 over 1,499. So it will become k, the k is 1.0336 to 4917. So that's the answer for that. So this is the equation we will be using. X of t equals the total population of college students, 1,500, over 1 plus 1,499 e raised to negative 1.0336. This is the k a while ago, and this is the days we'll be using 6 days. So if we calculate that, the answer will be x of t equals 372 infected students after 6 days. So that is the answer for this example. So that's all. Thank you for listening to us.